trig first, where it was just like kind of given to us in the form of our formula. And then we looked at what happens when I can't use long division or u sub, but we think maybe it's going to be an inverse trig. And so in this case, we completed the square and got tangent inverse. So we just have a couple more examples. So what's different about this one? Sine inverse. Okay, but again, remember we kind of want to go through our list because remember u sub is the one that happens most often, and it's kind of the easiest to do because we don't have to do anything else with it. So if we can use u sub, then that's what we want to try first. Can we use u sub for this one? As it is right now.
No.
Why not?
Because if you take the derivative of negative 2x squared, you get 2x.
Correct, and we have a 2, but we don't have an extra x. Agreed? So I kind of do u sub as it is right now. It's also not a good candidate for long division because notice I have a square root, and I would not want to do long division with a square root. Okay? But we do notice that we have a square root, and it's on bottom, which should lead us to kind of start thinking that this is a sine inverse, because our sine inverse is the one that has a square root in the denominator. However, as it's written right now, okay, is that in the form of our sine inverse? Nope. And the 24 is not a big deal. However, the extra x there in the middle is what's causing issues. So just like yesterday, we're going to complete the square. We're just going to complete the square with that stuff that's on the inside. And then we'll rewrite. So remind me, what was our first step when completing the square?
A equals 1.
Okay, does our a equal 1 right now?
A equals negative.
Yes, and so just like with when we had another number there, I do need to factor that. And remember that we really only need to factor it from the first two. Okay, what's our next step?
B over 2 squared.
Okay, what is b?
10.
Almost.
Negative 10.
Negative 10. Negative 10 divided by 2 gives us a negative 5. Negative 5 squared gives us a
Positive 5.
okay. Then what's our next step? I disagree. Yes, you do. Because notice that this negative also applies to this 25. So technically we already have subtracted 25. So to keep it balanced, I would need to add 25. And then our last step, which is kind of the whole point, is for us to factor. And we should end up with something that is a perfect square here. Which, as long as you did your steps correctly, you will. So now do we look like we are in the form of our inverse sine? Yeah. The 2 on top's not going to be a problem, right? It's just going to be a constant in the front. But instead of an x, what do we have right now?
X minus 5.
X minus 5. However, if we do an easy u sub with that, what is our du?
1.
dx. right? So do we really technically need to do the u sub? Not really, because it just ends up being that thing anyway. So I can go ahead and take the antiderivative, and we get sine inverse of u, or x minus 5, plus c. Also, I didn't talk about it, but remember, my a squared here is just 1, so remember that's technically we have x minus 5 divided by a, but since our a is 1, it's just x minus 5. What questions do we have on that?
If the a value was something that wasn't a perfect square, could you still take the antiderivative?
Yeah. So like right, if I have something like that, right, is that in my sine inverse form?
Yeah.
Yeah. The only difference here is that my a would be the square root of 5.
Okay.
Right? Because I can always, like, whatever's there squared, right? Or the square root squared is always that. It just happens to be like when I have a 25, the square root of that is just a nice number. So I get 5 squared is that. But if I have a 5 or a 2 or whatever, it doesn't look super pretty. But we can always just write the square root of 5, the square root of 2, whatever. Which is why I said at the end of the day, this constant doesn't really matter all that much, because I can always take the square root of 24. What really ends up hurting us is that x in the middle, and that's why we have to complete the square to fix that part. Alright, so let's look at one last one. So, what do we notice here?
There's no constant.
There's no constant, okay. Is that okay? Yeah, because remember with our completing the square, we end up having to add a constant in. Yeah, so that's alright. And then we also have an x squared and an x there. Yes? Okay. Is there anything that we might want to do from the beginning?
Make it negative 4x squared plus theta.
No, that's not necessarily an issue. Like when we start completing the square, we'll probably rewrite it.
Factor out the 4.
Okay. Why might we do that? Yes? Do we all agree with that? So now the nice thing is that now I have multiplication, right? And with multiplication, we are allowed to take the square roots of them separately. So this would just become a 2 in the bottom, so I get a 1/2. Now I am still going to have to complete the square here, but I have kind of nicer numbers now to do it with. So again, our steps don't really change, besides we just don't have a constant that we'll add stuff to. So our a value is negative, which if we think about, if we have a inverse sign, that's going to happen most of the time. Because, right, we're going to have minus our x squared, and so we kind of need it to be negative, actually. So most of the time we're going to have to factor out a negative. Then negative 2 divided by 2 is negative 1. 1 squared gives us a positive 1. And then what do we need to do in order to keep it balanced?
Add 1 to the outside. Subtract 1 to the outside.
It's one of those.
Subtract 1 to the inside.
We're going to add 1.
Add 1 to the outside.
Because this negative applies to this one, so I am already subtracting, so then we need to subtract a negative, which gives us a positive. Then what do we need to do? pretty similar to our last one. That one I take my derivative and just get a dx. So I get 1/2 arc sine of x minus 1. Again, my a value is 1 here, so just divided by 1. Thus, and the only reason I wrote arc sine is just to remind us that those two things mean the same thing, right? And we'll see both of them as answers and as multiple choice things, so don't freak out if you see one or the other because they're the exact same thing.
Question asked you for like sine inverse. Is it fine if you write arc sine
Yeah.
as the answer?
Again, they're mathematically equivalent. Other questions?